Okay, for this talk I want to cover FM systems in adults. This is based in part upon the reading Evidence for the Use of Hearing Assistive Technology by Adults, the Role of the FM System. So please go ahead and download that article attached to this link and go ahead and read that. Some other articles are referenced in this talk as well. As audiologists, one of the ways we can find out about what's most important for us to focus on is to figure out what our patients are having the most problems with. And one good way to do that is by looking at the Market Track survey. The Market Track survey is conducted every few years and has a fairly large sample for this particular Market Track survey, the Market Track 8. It's got about almost 2,000 subjects for their sample. This particular portion of the Market Track sample focuses on customer satisfaction, and specifically I'm going to talk about sound quality and signal processing. You can see that there are different categories here, ranging from clearness of sound, sound of own voice, naturalness, able to hear soft sounds, feedback, etc. If we look at the categories that have the lowest satisfaction rating, that would be total dissatisfied. We can see use in noisy situations of those hearing aids is the area where the satisfaction is the lowest. And if we look at the total number of persons that are satisfied, this is not exactly the opposite of total dissatisfied because we also have a neutral condition. But if we look at total satisfied, we can see that use in noisy situations is the second lowest number for satisfaction, the lowest being wind noise. So use of hearing aids in noisy situations is not really what we want it to be right now in terms of satisfaction and dissatisfaction. So a reasonable question to ask might be, why are these hearing aid users so dissatisfied, or at least not that satisfied as a whole? And recall that most hearing aid users probably have sensory neural loss. That's not going to be any kind of surprise to you. Whenever we have a loss of, say, pure tone average of 40 dB or greater, it's very common that we start to see a deficit in noise, so an SNR loss, as Mead Killian puts it. So when we're comparing the SNR thresholds for normal hearing subjects versus sensory neural impaired subjects, we typically see that there's the difference between the two groups is going to be greater than 0. So SNR loss of, say, 8 dB, for example, means that those persons with sensory neural hearing loss require a signal-to-noise ratio about 8 dB greater than that normal hearing group. Now, the average SNR loss for a sensory neural impaired group, 8 dB is a reasonable number. It really depends on which particular speech and noise test you're looking at. If you look at the Quicksin or the WIN, which is the words and noise test, you might see numbers between, say, 7 and 10 dB, depending on the study. If you look at tests like the HINT or the BKB-SIN, you're going to see smaller SNR loss values for the same exact subjects, and the reason for that is the predictability of those BKB-SIN and HINT sentences is going to be greater, and so those persons with sensory neural impairment can take advantage of those semantic and possibly syntactic cues to do better. So we might be thinking to ourselves, can't some of these advanced hearing aid technologies help our patients in noise above and beyond just amplifying in those areas where there's an audibility loss? The answer is somewhat. If we look at directional microphones, that's the technology that we know that has been time and time again shown to provide speech and noise benefit above and beyond just amplification, above and beyond providing audibility in those areas where there's the greatest audibility loss. As far as magnitude of benefit, we know it can be anywhere from 2 dB benefit to, say, 8 dB benefit, depending on a variety of factors, venting being one factor. The greater the venting we have, the lower the directional benefit. Another would be the exact conditions we use to test. So if we're looking at the ideal conditions where we see the greatest directional benefit, we're probably going to have speech coming from 0 degrees azimuth and noise coming from 180, and we're probably going to compare that to the noise condition where speech comes from 0 and noise is diffuse in all situations. And we may see smaller degrees of directional benefit with different conditions. So how about noise reduction? Many of our clients that we see will be under the impression that noise reduction improves speech understanding and noise, not because they've been told that, but just by virtue of the name. If we reduce noise, they feel like they're going to hear better in those situations because they realize that noise is the problem. The difficulty with that is noise reduction algorithms do not improve the signal-to-noise ratio. Time and time again, they've been shown not to improve speech understanding and noise. There are very few exceptions to that rule. There have been a couple noise reduction technologies that under certain circumstances have improved speech understanding and noise. Those have typically just been published in trade journals, though, so we don't really have noise reduction algorithms being shown to improve speech understanding and noise objectively in peer-reviewed studies. And the recent trend or craze has been to talk about binaural processing. Can binaural processing help our adult hearing aid clients hear better in noise? The answer to that is probably no. Possibly it could help a little bit with sound localization and noise, but it's not likely to actually, or hasn't been shown at least, to objectively improve speech understanding and noise unless we're using special features under certain conditions, say in the car or on the telephone. One last technology that I didn't really mention was frequency lowering technologies. I think there was one paper that might have shown nonlinear frequency compression might help speech and noise performance for kids with the BKB SIN. It's a possibility. It hasn't been shown in adults, and it hasn't been replicated. So overall, I think we can say that above and beyond amplifying, for our patients with sensory neural loss, directional microphones still remain the only technology within the hearing aid that's been shown to be able to improve speech understanding and noise. So we might ask ourselves, how well do directional microphones perform compared to FM technology? Is it a small difference in terms of hearing and noise benefit between directional microphones and FM, or is it a large benefit? Well, Samantha Lewis and colleagues set out to determine that. So in a paper published in 2004 in JAAA, Lewis and colleagues looked at the RTS as reception threshold for sentences with a background of noise. So basically they looked at a HINT, the hearing and noise test, and they looked at subjects in a variety of conditions unaided, so no hearing aids on, they have sensory neural loss. They also looked at subjects with omnidirectional microphones on their hearing aids, subjects with directional microphones on their hearing aids, and then subjects when they're wearing personal FM units attached to their hearing aid, either monaural FM, so FM just attached to one of their hearing aids, and binaural FM, where FM is attached to both aids. You should also notice there is Site 1 and Site 2 within this bar graph here. The same exact study was replicated at 2 separate sites, so we have replication built into the study to increase the validity of it. Site 1 in this study was the University of Florida, Gainesville, and Site 2 in this study was the Washington University School of Medicine in St. Louis, Missouri. Site 1 had 22 subjects, Site 2 had 23 subjects. Median age for both sites was 73 years old. There wasn't a difference really in the overall distribution of age across sites. However, there was a significant difference in mean audiogram across site, with Site 2 having poor audibility on the pure tone audiogram. Configuration, it was a kind of a gently sloping sensory neural loss for subjects of both sites, but probably about 10 dB worse or so at Site 2. So for Site 2, we're talking about pure tone average roughly around 55 dB when it was about 45 dB or so for Site 1, maybe 40-45 dB for Site 1. And for this study, the noise source was diffuse, so we had noise coming from 4 different speakers, 45 degrees, 135 degrees, 225, and 315, so really all around the subject. Whereas the speech is coming from 0 degrees azimuth, so right in front of the subject. So go ahead and look at the y-axis for this bar graph on the screen for the HINT. Higher numbers, so above the 0 axis, are going to be poor speech and noise scores. The lower we are on the y-axis, the better the speech understanding and noise. the noise level was fixed at 65 dBA, and the intensity level for the sentence material was altered or bracketed until they found the 50% speech recognition threshold. For the hint sentences, if you're not terribly familiar with them, it's pretty much about the same sentences that you see in the BKB sin, so they do have some syntactic and semantic cues in there, so kind of easier sentences at a elementary school level. When they're scored, the sentence is either entirely correct or entirely incorrect. And then the bracketing occurs in 4 dB increments and then later 2 dB increments. So some things that we can see from this bar graph are that for both sites, the poor speech understanding and noise performance occurred in the unaided condition. So for site 1, the mean RTS was about 5 dB unaided, and for site 2, it's about 7.5 dB unaided. Performance in the omnidirectional condition was significantly better than unaided. In fact, it was about 5 dB better than unaided. When comparing the performance in the directional microphone condition versus omnidirectional, we can see that there is also an improvement that occurs. For site 1, it was on the order of about 1.2 dB, and site 2 was a little under 3.5 dB. So not nearly as great as we've seen in previous studies for the benefit with directional microphones, but definitely an improvement over the omnidirectional condition. But again, not to the same magnitude of improvement when we compare omni to unaided. And I guess probably one of the more important findings was the dramatic improvement that we see when we compare the binaural hearing aid fit to a monaural FM fitting. This improvement is on the order of about 14 dB or so when we compare site 1 with monaural FM compared to site 1 for directional hearing aids, and it's greater than 16.5 dB improvement when we compare monaural FM to bilateral directional aids in site 2. And lastly, when we go from monaural FM to binaural FM, we see another significant improvement in speech understanding and noise. We see a lowering of the RTS by about another 2.5 dB for both site 1 and site 2. So to put things into perspective, the magnitude of improvement we see from going from monaural FM to binaural FM is roughly the same as the magnitude of improvement we see going from omnidirectional microphone to directional microphone. So one thing you could be asking yourself there, what are the clinical implications of this? And I suppose there could be several different takeaways. One would be the dramatic benefit that we see going from any kind of hearing aid condition to FM is going to be huge. So a person who may not be understanding well in any kind of situation where distance, noise, or reverberation is a problem, in particular distance, then I think it's easy for us to see that significant benefit can be achieved. If there's a cost issue, where say for example, say they can afford the transmitter and only one FM receiver, and for whatever reason maybe we can't get a second FM receiver for the client due to cost, we can see that there's still tremendous benefit with a monaural FM. It's not quite as good with a binaural compared to a binaural FM, but it's still probably going to be adequate for most listening environments. So as you've kind of heard in the previous talks that have been posted online, the pediatric population is by far the population that is most commonly served with FM technologies, in particular in the educational classroom setting. And it's been shown time and time again to be effective for improving speech understanding and noise for those pediatric populations, but it's also shown to be quite effective for adult populations as well. And just a couple different populations we can break this down into. For adult users would be hearing aid users, which cochlear implant users, and then those users with normal hearing sensitivity, but substantially greater speech understanding and noise deficits than the normal hearing population as a whole. The first real systematic study to investigate the benefits of FM technologies in older adult hearing aid users, or even non-hearing aid users, and probably still the largest study for adult FM, was conducted by Jerger and colleagues They recruited 180 elderly hearing impaired subjects, and they utilized a high quality research design, so randomized crossover design. Subjects were randomized to different conditions, and then the different orders of conditions, looking at unaided condition, the hearing aid condition, hearing aid plus FM, and then FM only. Of those 180 subjects, about 100 were previous hearing aid users, and 80 were new hearing aid users. Each condition that they were in, again, unaided hearing aid plus FM, and FM only, each condition was conducted in the real, or was experienced in the real world for about 6 weeks. When the performance was measured for speech understanding and noise within the sound field setting, using the SPIN, which stands for Speech Perception and Noise Test. That's a sentence test where the key goal is to repeat back the last word in the sentence. There's 2 different types of sentence material for the SPIN test. There's high context and low context sentences. In the figure on the right side here, panel A on the top represents performance with low context sentences, so ones that are less predictable, and panel B on the bottom represents performance with high context sentences, so sentences that are more predictable, easier to guess. We can see the most dramatic differences going from the unaided or aided condition to FM, regardless of the FM has a hearing aid attached to it or not. And we could see the differences are a bit larger when we go with the low context sentences, so when we're relying primarily on audibility and we're reducing the impact of the user's linguistic knowledge. Besides the speech and noise measures, a variety of outcome measures were administered. Most pertinent would be the hearing handicap inventory for the elderly. For the scores on the hearing handicap inventory for the elderly, there was a significant improvement with any of the 3 treatment conditions relative to unaided. So hearing aid or hearing aid plus FM or FM only, all of them were significantly better than the unaided condition, but none of the 3 treatment conditions were significantly different from one another. While anecdotally, many of those subjects indicated they preferred the sound quality with the FM system, 175 of the 180 subjects, when asked, chose to use the hearing aid from day to day alone without an FM system. One of the suggestions by the authors of this study was that the bulky nature of these devices could have been what deterred certain subjects from choosing to use them on a day-to-day basis. I think other factors could have been financial considerations, and it's also possible that the FM system benefit was overestimated in this type of study. For example, if we think of the low context versus high context sentences, we can see that the low context sentences showed the greatest benefit, but in everyday life, we're probably going to be experiencing high context sentences. And the other aspect to consider that I don't think was mentioned by the authors is the benefit we receive from vision, from speech reading, and so that could have also potentially reduced the day-to-day benefit as well. In 2004, there was another paper that came out, this time by Arthur Boothroyd, looking at 12 subjects in a variety of conditions. We've got normals and noise were being compared to hearing aids and quiet, hearing aids and noise, and FM systems and noise. We can see the data from each of these 12 subjects in the figure on the right side. We can see overall, when we compare these 12 subjects, they pretty much always do worse than the normals and noise. Normals and noise being the very light dotted line curve for in each of these 12 panels. One of the key observations made by Boothroyd in this study was that for these subjects that were aided, they typically, with the FM and noise, they typically do no better than they would do with hearing aids and quiet. We can see that all of these subjects seem to benefit using FMs and noise relative to hearing aids and noise. The magnitude of the effect varies depending on the subject, and it also is going to tend to be larger for the most difficult listening conditions. So here on the x-axis, when we move to the left, where when aided, these speech levels are softest. So essentially those are going to be the poor signal-to-noise ratios when we have a fixed noise level in the background of 55 dB/SPL. These same subjects, when surveyed, responded as far as where they found the FM system to be most beneficial, to be no help at all, and where they just didn't use it in general. And so these responses in the figure on the right side for perceived benefit, these are rank ordered from where they received the most benefit up top to the least benefit at bottom. So we can see one person in quiet at a distance or one person in noise at a distance. We can see subjects in general, almost universally, felt like they received the greatest benefit at a distance. We can also see, conversely, that the least benefit was obtained one person in quiet close, for example. So when distance was not a factor, when the person was close and there was no background noise, there really was no benefit from that. And then under certain circumstances, for example, listening to the radio, the subjects just didn't use it at all. And this was over the course of a 2-week trial period. These subjects were kind of living in the real world and reporting back their responses from their experiences. A couple other notable things that I should probably mention about this study. Of those 12 subjects in this study, none of them actually intended to obtain the device per Boothroyd's report. He expected that clients, considering they had reported some of the many benefits that the FM technology had provided them, that they would inquire at least to the cost of these devices, but none of them even expressed an interest in what the cost was, so very likely it wasn't even a consideration for them. So it seems up to this point that it's been pretty clear from previous studies that adults with hearing aids or adults with hearing loss in general can benefit in hearing and noise with FM technology, but one of the biggest problems is going to be adoption. And so Chisholm and colleagues, connected with the VA system, wanted to first target subjects that they thought would be more inclined to be more likely to be successful FM users. So they wanted to find those who had at least a moderate postlingual hearing loss with no evidence of retrocochlear dysfunction. They found these subjects who really weren't terribly satisfied with their hearing aids in at least one environment. And that environment would have to be one where they thought FM could adequately address it. These were BTE hearing aid users, because we know that FM systems are going to be more compatible with BTEs relative to custom aids. I realize you can use an FM with a neck loop with some custom aids, but we have the option of the direct audio input device with BTE aids, and no known neurological psychiatric diseases that might have may preclude successful hearing FM usage. At the start of the study, they found 44 volunteers across 2 different sites. However, 8 of those 44 volunteers withdrew, some of them because they had in-the-ear hearing aids, others because they really weren't willing to use BTE hearing aids. 2 of them reported that they were no longer dissatisfied with their hearing aids, and 3 withdrew because of family or health problems. So there ended up being 36 of these subjects, average age of 75, which is pretty similar to the previous studies for average age of FM users. So these 36 subjects went through a 4-week trial period, and at the end of the trial period they were given the option to continue using the FM system if they wanted. All 36 subjects ended up continuing using it, and of those 36, 30 of them were still using them after 12 to 18 months. These researchers looked at a variety of measures, including the COSI, the CPHI, which stands for Communication Profile for the Hearing Impaired, which is a very long, approximately 150-item questionnaire. I'm just going to go over some of the outcomes that are, I think, more interesting. So if we look at the results from this communication profile for the hearing impaired, we see the ratings for the individual subscales down at the bottom there. We've got the hearing aid only condition, which are the black bars. We have all 36 subjects after the 6-week period with those light gray bars, and then we have those 30 subjects that continue to use the FM systems after a year with the darker gray bars. So we see the darker gray bars are only on the right side of the panel because those are the 30 subjects who would actually have a response after the 1 year. If we start on the right side, we can see that between the 6-week and 1 year period that there is a reduction in the score, and higher scores are better for this communication profile. So overall there's a little bit of a reduction between 6 weeks and 1 year. But for either the 6-week period or the 1 year period, we can see that there is a substantial difference between the hearing aid alone and the FM conditions for all of these subscales: social, work, home, adverse listening conditions, and then overall the average score. When global quality of life measures were looked at, we can see that really hearing aid versus FM, there was absolutely no difference in quality of life measures. So it may be those quality of life measures just weren't sensitive enough to pick up on any kind of effect related to the FM. Then when asked about, for these hearing impaired subjects, for how percentage of, I believe it's number of subjects who were feeling embarrassed or ridiculed or rejected as a result of their hearing loss, they found that there was a fewer number of them that had those feelings with the FM system relative to the hearing aid alone. And that's displayed here by seeing that shift from the bars to the right when we go from hearing aid alone down to FM. When we look at satisfaction outcome data, we can see that the users of the FM were more satisfied in noise and for hearing soft sounds relative to the hearing aid only condition. And there's no difference between the improving hearing, reliability, visibility for the satisfaction ratings. When subjects were asked what they would be willing to pay for an FM system, giving them kind of a reference that hearing aids usually cost about $4,000 a pair, because remember, these are subjects from the VA who aren't going to pay for hearing aids or FM systems. So they were given a reference that hearing aids usually cost about $4,000 a pair, and they were asked to give some kind of value, willingness to pay value for the FM system. In the range they were given, it had to be somewhere between $150 and $10,000. The average response was about $2,509. Now this was lower than the MSRP of the FM system, the manufacturer's suggested retail price of the FM system, and so only 10 of those 36 subjects were willing to pay the MSRP or more. So definitely cost may be a barrier for FM system use. It is hard to know how this data would apply to the non-VA population, if their characteristics would be the same, and if these will generalize to them. We really don't know the answer to that. So overall, I think it's pretty clear that FM technology is beneficial to those hearing aid users who have difficulty in a background noise. We can say that I suspect that cost is probably an issue, so it may be easier to get hearing aid users to adopt and regularly use the FM system within the VA system. Of course, the majority of audiologists don't work in the VA system, so when we're talking about adults in hearing aid practices, so one is going to be cost. Now, one possibility would be these newer remote microphone technologies that are either coupled or not coupled to an intermediary Bluetooth devices. So say, for example, the NFMI technologies, so near-field magnetic induction. When we look at Oticon and Phonak and Siemens, they're all using near-field magnetic induction where they've got some kind of intermediary device. Right now, Siemens has the EasyTech, Oticon has the Streamer Pro, I believe, and Phonak has the ComPilot or the ComAir, I think ComAir Pilot. And all of those are devices you have to wear as an intermediary, and then you can have a remote microphone coupled to the spouse or other person's shirt. And those, while they have a reduced range relative to FM systems, they could potentially produce similar effects or benefits. Other manufacturers are using different technologies. For example, Resound has a 2.4 gigahertz microphone that does not require any kind of intermediary device. Starkey has their SurfLink Mobile, which is a 900 megahertz technology, and that's a small device looking somewhat like a small cell phone, which can be placed on the table. And both Resound and Starkey have made for iPhone products where you can use your iPhone as a microphone to transmit directly back to the aids. So I think cost is an issue that will be is going to be significantly addressed by these new remote microphone technologies. But we still have to make sure to counsel patients regarding these technologies. I think they're going to be less complicated probably than the FM technologies were, but extensive counseling may be required for subjects. Those with cognitive impairment may not always be a good candidate for using these remote microphone technologies. And then lastly, we probably need to see peer-reviewed studies that show that these are going to be as effective as FM technologies, because right now I believe there's only data that are published in trade journals regarding these types of microphones, but so far it looks very positive, and theoretically I don't believe there's a great reason to believe that they wouldn't be as beneficial. So I'm hopeful in that area that our patients can start receiving these benefits sooner rather than later. Okay, so I've talked about the benefits of FM in adults with hearing aids. I want to move on to adults with cochlear implants now. So we know that adults who have at least a severe sensorineural hearing loss or worse are candidates for cochlear implants. And we also know that while improving speech understanding in a variety of areas, say quiet and even in noise, that persons with cochlear implants still have tremendous difficulty hearing in noise. So can cochlear implant technology be beneficial to this population? Well, that's what Aaron Schaefer and Linda Thibodeau set out to find out. And so this report comes from a paper published in 2004 in JAAA. They compared several different FM systems in 8 cochlear implant subjects. They also looked at 10 normal hearing subjects as well. The image in front of you here on the right side shows different ways that FM systems would be coupled to cochlear implant processors back around the time the study was conducted. You notice that there are body-worn and ear-level processors here. Now they're predominantly all ear-level processors, but back at this time here there were body-worn processors, and you can see the different methods of coupling these systems depending on the type of system, going from the top to the bottom. We have the phonic ear easy listener at the top. In the middle we have the AVR Sonovation Logicom, and on the bottom we have the Microlink. So in this figure here we can see the benefit of a desktop FM system. They call it a totable FM system, where you've got like in a school setting, it might look like kind of a lunchbox that has a speaker built into it that you might have in front of you, about maybe 1.5 feet in front of you or so. We can see that the normal hearing group had a substantial benefit in the noisy environment, going from no FM to desktop FM, but we can see that the cochlear implant group had a much smaller benefit, going from no FM to totable FM. Anytime we're talking about percent correct scores for speech, I probably need to go ahead and let you know what the materials they used here were. It was the HINT, so the hearing and noise test, which are semantically and syntactically, they're high context sentences, so they're easier sentences in general. Usually with the HINT, we're establishing a reception threshold for sentences, so like an SNR threshold, but in this case it was modified. They were looking at the number of words scored correctly per sentence in different fixed signal to noise ratios. And they did that because of the difficulty of the normal HINT for the cochlear implant users. So if we look at the individual data for these 8 cochlear implant subjects on how they did unaided without the FM, with the cochlear implant, but without the FM in noise, those scores are on the x-axis. And when you, so subjects 1 through 8, we have 8 different vertical lines, 1 for each subject. And their score that vertical line intersects on the x-axis represents their cochlear implant only, no FM score. So if you follow the line upward, you'll see three different symbols. You'll have the diamond, which is how they did with the desktop FM, which they call totable here. and then you'll have two different personal FMs. One is the easy listener and one is the Logicom. So easy listener with the square, the gray square, and the Logicom with the white triangle. Both of those are personal FM systems, just different brands. What you'll notice is that pretty much every subject is going to benefit relative to the unaided condition. I think, or not every subject, but every subject when using the personal FM system, I believe, is going to benefit. Now, when they use the totable, that's a little bit different story. Not everybody, the benefits overall are much smaller with the totable, and not every subject seems to receive a significant benefit with the desktop FM, the totable. Now, two subjects in particular are probably worth pointing out. If you look at subject 7 and 8, it shows that they did the worst with the totable. It's worth mentioning these two subjects had Nucleus 22 processors that when you plugged in an FM system, the environmental mics turned off. So for this, they're basically, the environmental mic is there's no benefit of the FM system probably with these two subjects here with the diamonds, the black diamonds for the totables. So you might kind of disregard those two, these two marks, you might disregard them. But overall, you can see that there's a substantial benefit for personal FM. It's much larger than with the desktop FM units. If we want to look at FM benefit by taking their score with the FM minus their score with no FM, we can see how much improvement they get. So the y-axis is how much improvement or benefit they get by adding FM. The x-axis is their the effect of noise, basically, what the negative impact of noise is for these individuals. So the more negatively they're impacted by noise on the x-axis, the greater the benefit for FM on the y-axis. We've got two different types of symbols here. We've got the squares, which is FME. That's going to be the 6 of the 8 cochlear implant subjects where they've got the FM system plus the environmental mic turned on. The dark circles, the black circles, represent those two subjects. When the FM is plugged in, those environmental mics turn off. But all 8 subjects is only 8 data points. I realize it's very limited when conducting a correlation analysis, but it was a very strong correlation of 0.71. So it seems to be the more negatively they're affected by noise, the greater the potential benefit for FM. I think it's reasonable to be fairly confident in that assertion. Finally, the last group of subjects I wanted to cover with FM systems were adults with multiple sclerosis. The point of covering this particular topic is the idea of individuals with speech perception and noise deficits without peripheral hearing loss. So this idea of using it with multiple sclerosis is more of an example than anything else. You could extend this to patients with obscure auditory dysfunction, auditory processing disorder, other types of neurological impairment where speech perception and noise is going to be poorer than normal. So just a little bit of background on multiple sclerosis. It's a disease of the central nervous system in general. It's an inflammatory disease. It typically is going to affect a variety of different systems, vision, motor movements. It's going to affect the cerebellum, brainstem, cerebrum. So it's pretty diverse as far as its effects. Prevalence of hearing loss in MS, the ranges vary so widely that it's almost not useful, anywhere from 1 to 86%. For pure tone sensitivity loss, somewhere as far as like mile loss, about 40 to 60%. So studies looking at specific auditory processing abilities with subjects with MS, independent of pure tone hearing loss, have shown dichotic listening deficits, auditory temporal processing deficits. So it seems to be that there are some more central auditory processing deficits within this population, and that really isn't terribly surprising considering it's a degenerative disorder of the CNS. Lewis and colleagues within the VA system looked at 10 subjects who were diagnosed with MS and 10 that did not have MS. They had an average age of around 50 years old. For the group with MS, 47 years old was the average age for the group without MS. They were all between the ages of 21 and 65. The average pure tone audiograms are shown on this slide here. We can see that the group without MS has completely normal hearing, around 10 dBHL or better for thresholds, slightly worse hearing for the group with MS, in particular at the high frequencies around 4,000 and 8,000 hertz. This kind of study, it's difficult to totally match pure tone thresholds because there may be some inevitable change that occurs with the disease process, similar to aging in general. Very difficult to match older adult subjects with younger subjects for normal hearing. There's going to be an inevitable component in terms of changes in pure tone sensitivity. In terms of subjective report of auditory symptoms, we can see that the MS group has a considerably higher number of complaints reported than the non-MS group. We can see here's some data showing the MS group for speech understanding and noise versus the non-MS group, and this is without any FM system. These are going to be using the IEEE sentences. Those are pretty much the same sentences that you see in the QuickSyn with the background of multi-talker babble. I don't believe it's the same babble that you have in the QuickSyn though. So similar to the QuickSyn, percentage of keywords correct on the y-axis. On the x-axis we have SNRs, so poor SNRs to better SNRs from left to right. We can see at each SNR that the non-MS group typically scores significantly better than the MS group. And if we go ahead and look at how the group with MS performed using an FM system, we see unaided is without FM, aided is with an FM system. There were significant differences in performance between -6, -7, -8, -9, -10, -11 dB SNR. So I'll see if I can go ahead and kind of circle that range here, going up here around -6, and hopefully I can get it approximately. Not that great at circling that, but this is the range where we see significant differences occurring here from -6 to -11 dB SNR. So the improvements we're seeing here are on the order of between 30%, which is at -7 dB SNR, up to 47% improvement, which is at -8 dB SNR. So above that, we start to see the effects of the ceiling effects. Below that, we start to see floor effects. And the main message I wanted you to take away from this is that for those subjects who may have fairly normal pure tone sensitivity, who may not be the best hearing aid candidates, first performing speech understanding and noise tests may provide you with new information that you wouldn't otherwise have. In this case, it would be with a population that we don't ordinarily think of as being associated with auditory difficulties. So those with CNS dysfunction, where there may be an impact, there's a known impact of auditory deficits, or where there's a reported auditory deficits, that speech and noise testing may be beneficial. And in particular, this type of intervention may be appropriate depending on the severity of those complaints. So for those, not just with MS, but with those adults that have non-peripheral auditory dysfunction, FM systems may be a viable option to improve quality of life. And that's all I've got here for this talk on FM in adults.